Type generics is a very useful feature in TypeScript. They allow you to create reusable functions and types in the TypeScript world. You know how in JavaScript you have reusable functions, for example, this sum function, which takes an array and adds everything in that array, returning one value, and we can use this function with different values. Well, in the TypeScript world, you have something similar, which is generic types, where instead of passing values like this, you can pass types. And in this video, I'll be helping you understand how generic types works. I'll be looking at some examples to see how useful they can be. Now take a look at this example. We have this function called getRandom, which takes an array and then we get a random value in that array. I'm just using an index of 2, but you'd have some logic here to get that value at random. Now here we have these two arrays. This is an array of string and this is an array of numbers. And then here we're going to have random fruit, where we get getRandom from the fruit array. We have random score, we have getRandom, and the scores array. Now the first problem here is that this array is not typed. So by default it has an any type. But if you're using any here, what you see is that random fruit has any, random score has any. How do you type random fruit to have string since we're getting a random fruit? And how do you type random score to be number since you're getting a random number? Instead of any, you might think, okay, an array of strings or numbers. Now in this case, you can pass an array of string, an array of number, and now random fruit is going to be a string or a number. A random score is also going to be a string or a number. We have solved the problem a bit, but how can we be more specific? How can we say that random fruit is a string and random score is a number? Well, you might think to use a type assertion like as, to say as string and here as number, and now random fruit is a string and random score is a number. But there's a better way you can do this, which is with type generics. So how does type generics work? Well, when we come back to this array, first you can create your variable. Think of this as a type variable. Again, in the TypeScript world, you can call this anything. Usually you'd see people call this T, some people will call it U, but let's just call ours item. Now we have this variable type item. Instead of having this string or number, I can do it like this, an array of items. And then I can say that this should return an item. So what we have here is a variable type. So as at the time of creating this function, TypeScript does not know what the type of item is. You are the one who would tell TypeScript what the type of item is when you are calling the getRandom function. So here when we're calling the getRandom function, I can now pass a type for this variable. So for this, I'm going to say string. For this, I'm going to say number. So when I pass string is going to replace item here. Then this array is now going to hold an array of strings like this. Going to put this back, and it's also going to return string like this because string is what we put for item. And in the case of number, that's going to be the same thing. Number would replace this and also would replace this. Now if we should highlight on getRandom, what you see is we have getRandom string, an array of strings returning a string. And if we have getRandom here, it says getRandom number, an array of numbers returning number. And now when you highlight on random fruit, you see we have string. Since we pass string here as the item and we are returning item here, random fruit is a string, random score is a number. And let's say I have an array of users. So I have this type user, name string age number. I have an array of users. Here in my random user, I can say getRandom and I can pass this user type. And now you're going to see that random user has this user type, which is name and age. So with type generics, we have been able to create a reusable function here where we can specify the type of items that is going to be in an array, and we can use this for various types. Now that thing to note here is type inference. So here we had to pass this string like this to tell TypeScript that this string is going to replace this item, but we can also choose not to pass it, and TypeScript is going to know that item should be a string in this case. How does TypeScript know that? Well, here we say that this argument, we typed it by saying it is an array of this variable type. So now when we pass fruits, fruit is an array of string which TypeScript infers here. So since fruit is an array of string, if you come here and you have string like this, TypeScript knows that this string is referring to item because we had it like array of items. So now you see that random fruit is still a string. If I come here and I remove this number, you see again that random score is a number because this is an array of numbers. So TypeScript can infer that item is a number. Same thing here, I can come here and remove this and TypeScript can infer that random user is the user type because this user's array is an array of this. Let's look at another example. I have this function called gets from storage. It takes a key, which is a string, and it gets something from storage and it passes it. It can get a number from storage, an object, maybe an array, and then it returns that item here. Now in this case, we probably want to get a user object. In this case, we probably want to get a team string. We can use type generic again. Here we can say item. Again, you can call this anything and we want this to return item. Then here, since we're expecting a user object, we can come here, pass our type to say we are expecting a user object where the name is a string. And here again we can pass a type saying that we want to get a string from this. And now you can see when I highlight on this, you can see that the return value is name string, and if I highlight on this, you can see that the return value here is a string because we used item here and item is the variable type. You can also use type generics with interfaces and types. Here I have an interface called storage item. You can see here again it takes a generic type. Now this storage item has a key of string and a data where we pass the generic type here. Now here, let's say I want to get a user from storage. Here I have this user type. I can come here and say const user and then type it to be storage item, where I'm going to pass, you can see it's going to say that generic type storage requires one type argument. So here I can pass that I want to get a user from the storage. And now what you're going to see now is I need to provide a key, something, then I need to provide a data which is currently typed to the user type, and I need to provide an object where I have the user type name, Deeecode, and age 40. So here we're using a generic type with an interface, and instead of having an interface, you can also use a regular type like this. We have the type, we have the generic, you pass the generic wherever I want to use it, and then you can use it like this. And you can use multiple generics. In our type here, we're using just one generic type T. You can have another generic type. Let's say I want to have a generic type here called key, and then I'm going to call this data. So I can pass the data here, and for the key, I can pass the key like this. So for the key, I can pass string, and then I can pass user object. I can also pass number if I wanted. I can pass anything that I want to be the key, which is going to be used here. And now you can see when I pass a key of number, this key doesn't work again because we have string. But if I change the key to number, everything works fine. I can also pass default values or default types for your generic types. Just the same way you pass default values for your function parameters, you can do the same thing in TypeScript. So here I can say that key is string. This is a default type, which means if I don't provide a key is going to be string. But then we have another error here that says required type parameters may not follow optional type parameters. What this means is if you want to have an optional type parameter, then it needs to come after the required one, which means if I just have user like this, then key is going to default to string. And now you see I have error here. If I provide a string, everything works. But then if I want my key to be something else, then I can provide that something else. And here I can now use a number as the key. Another interesting way you can use type generics is with the keyof keyword. Here I have this object called Dutch translation, where I have the English as the key and the Dutch as the value. And then I have this function called getTranslation. It takes a translation map object and it takes the English so I can return the translation. Now here when I call getTranslation and I pass this Dutch translation object, you can see that I am passing a key that doesn't exist here. Now, how do I ensure that I am passing a key that exists on the object that I am passing? Well, we can first use type generics. So here I can receive a generic type. I'll just call this T, and then I'm going to type this translation map to T. Now for this English, what I'm going to say is instead of saying string, I'm going to say keyof T, which means this English is going to be a union type of the keys in this T type. Now here when I'm using getTranslation, I can now pass the T, but then I cannot pass Dutch translation because Dutch translation is a value and not a type. So here I can pass type of Dutch translation, and this is going to return the Dutch translation type, which is hello string, good morning string, difficult string, grammar string. And now because the English is keyof T, it means I can only provide the keys in this type. So now as you see, I'm having an error here. Type something is not assignable to hello, good morning, difficult grammar. But if I pass difficult here, you can see that everything works fine. And it doesn't matter the object that I'm passing. Let's say I have another object here called random translation, where I have the English as something and this is the translation. I have hello and this is the translation. By the way, you should subscribe to my YouTube channel if you're enjoying this video. Now when I have this, I can come here again, call getTranslation, pass type of random translation, and here I have random translation. And what you see here again is that difficult is not assignable to hello and something because hello and something is coming from the keys in this object. But when I pass something, you can see that everything works. Again, we have been able to create a reusable function by passing a generic type. As at the time we created this function did not know what type it was going to expect. But when we use the function, we're able to pass the type that we expect. Here we pass type of Dutch translation. Here we pass type of random translation. Remember, TypeScript can infer the types. So I don't even need to pass type of Dutch translation. I can remove this line and I can remove this line. Now what's going to happen is that when we pass Dutch translation, TypeScript would infer the type of this object, which is hello string, good morning string, and the rest. And when it infers that type, it's going to assign it to T. And now that TypeScript knows what T is, it knows that the English is going to be keyof T. Same thing with random translation. TypeScript infers that this is the type of random translation, and then the English is going to be keyof the type of random translation. And now we have this. We don't have to put the brackets here because TypeScript already knows. And now we cannot pass any key that doesn't exist in this object. We cannot pass any key that doesn't exist in this object thanks to TypeScript generics. Well, and of course the keyof keyword, which I just showed you. I hope that these examples have shown you how useful type generics can be. As you can see, it allows you to write reusable code where you can reuse types in different ways. You have your function can receive any type, and you define those types when you want to use that function, or you define those types when you want to use that interface. There is two more things you can do with generic types, and I'll be making more videos showing you a lot of these other use cases. So if you enjoyed this video, please give it a like, share it with others, and also subscribe so you don't miss out on my upcoming TypeScript videos like this.